But
Hi, folks. Before I start, I have a couple of survey questions. How many of you were at the LPC in September last year? Okay, it's a significant bunch, and I assume all of you were at the scheduler track. You were there. You also threw a mic. And I'm assuming everybody in this room knows what RT app is. Okay, great. So I'm going to do this without slides because I really need this to be an interactive discussion. So if anybody's tired, sleepy, stand up. Sorry.
that's just not going to happen.
No?
You have to do the last one.
Yeah. Joe? Yes. So I work for Oracle, and I'm on the dark side. I'm a manager now. And one of the teams that comes to me is the scheduler team. And you have heard some of our problems right now. One of the things I realized talking to Peter yesterday is that there aren't many people who are working, but many scheduler folks are working on big systems right now. All the work's happening in the embedded space, ARM space, Android, energy aware, things like that. At least, most of the development. And what's happening is, we go the exact opposite way. We're going to break your use cases. You guys are going to go the other way, and we're going to break our use cases. And Yuri, what he mentioned back at LPC last year was for a lot of the CPU Frex stuff, you guys use RT app traces to see how things are going. And one of the discussions that happened at that point, one of the decisions that was made at that point in time is it would be a great idea to have a collection of these traces together so that we could run RT app uh, and see how it works for different use cases. In our case, for example, we would make Oracle DB running some sort of workload we care about up and running. I don't know, what would be your
Well, when you say traces, you mean JSON?
yes, the
Right.
RT app JSON.
Yeah, I guess we actually discussed the same thing a few months ago. Concluded
Yes.
that it should. Yeah.
Yes, and so I want to move off from that. So, I actually went back and I have an okay from my management to go ahead and make this available. And I started working on that. I had a guy working on that, and then he left. And then there's this big microprocessor company which had issues, which had all of us really distracted for a few months. So we were planning to get our stuff out by now, and that did not happen. But going forward, I mean, what are the workloads people are interested in? What should we be collecting? Where should this go? Should it be a part of the RTF project? Should it go somewhere separate?
And also how to interpret the recent damage.
Yes. So what tools are needed in the ecosystem?
Trying to
Push this up.
so I can see RTF
Uh-huh.
capturing to any sensible degree what Oracle DB does because it has no memory footprint whatsoever.
Right.
So it's fun.
You can have,
Oh, you can have memory
you
failure.
can have some memory
So
rather
it's
than file
fake.
system as well. Not quite simple, but we can extend that.
Yeah. So let's start making notes so that.
Yeah.
So your objection is memory more.
System, system access, memory access.
I think in general he's objecting to the weight, which is memory and I/O, and you don't know what's happening to cache. And what
Right.
the
Because that is a very large part of the database workload.
Correct.
Probably what you are interested in is like a performance number,
Mm-hmm.
which probably RT app is not giving you right now.
Yes. So what we talked about
because
was
of proxy for completion time for a task.
You mean Slack?
Yeah.
Slack stuff?
Slack.
Yeah, but this has,
but we want
it's not as easy as Hackbench, right?
Yeah.
To understand.
It's not working once, but you need to pass the law.
Yes. Right. Well, and the ability and Slack might.
I mean, just to take a step back, I mean, we're talking about RTF right now because it exists, but if there is a different synthetic workload tool generator.
No, the problem is just that's why we like to use Hackband, for instance, right? Or Sysband, because you can
Gives you a number.
At the end, you have a number in 5 minutes or even less,
Right?
which is not which is not right as easy as with RTF right
It's
now.
just generating the workload. It doesn't give any numbers.
Right, and that has to be analyzed in the end. So Peter's objection, I remember then, was you need a brain to actually understand
Exactly.
what's.
Yeah, and also this is what we ran in when Joseph was trying to record his funny Facebook workflow. For replay, you need one, a very, very similar system, and two, I never got to.
This is what Bob was going.
This is what Joseph did the VPF to JSON conversion thing.
Okay.
And Sam also played with that, and I don't think we ever saw what he was seeing. It was very.
No, that's, yeah, it doesn't capture the configuration the JSON was generated on.
But Peter, we don't. What we need to know is that we haven't caused a regression for another workload. So it doesn't matter whether we have the same system or not. As long as with my patch and without my patch, there is no regression.
Yeah.
Sure, and that's.
I mean, if you recorded an 8-node system, and I run it on my desktop, my desktop will just grind to a halt for a while, sit there, being very busy, but the end result might not have any meaning whatsoever. So that is part of the problem, of course.
But what's the end target here? You want to have like a set of RTF workloads running on Linux X or something, or
I mean,
changes on Linux?
no, I don't care about Linux Next. What I do care about is, let's say EAS folks come up with something and then start packing them onto a core, or onto a node, for example. I mean, I don't know what the end effect is. I don't want it affecting our workloads. I want to know about it sooner rather than later.
But what you should then do is make sure you can run an Oracle workload in minutes instead of days.
Yeah.
Yeah,
Yeah, but that must be.
So in our, we are trying to use a slightly different approach, which is we would like that if the tool fails and we have a regression, we also have a little bit of indication what is failing, why it's failing, right? So we would like to be able to pinpoint possibly the code line or the residual patch that changes that behavior. That's why we are trying to use RTF to describe synthetic workloads that are really simple and try to stimulate or generate one specific behavior that you can see how the scheduler behaves, right? So for example, we have a task that in case of big little is starts small compared to the capacity of a little CPU, and then after a certain time becomes big, and we want to see that the scheduler migrate this task as soon as possible on a big CPU. Right, so when these things fails, we are not getting a matrix of performances whatsoever.
Right.
But you know that the migration, when a task is misfits, is broken. And you can look at the code where it's
functional testing.
Yeah, it's behavioral testing code. So try to identify behaviors that can be disconnected from numbers, but they are really simple and potentially linked to a scheduler.
The thing is, I can, for example, the benchmark on CLPs.
Sorry.
Exactly.
Yeah.
Right. No, but RTF, we're not looking to use RTF as a benchmark. What we're looking to is.
That's why it's hard to compare.
Yes.
But what you're describing, what people say when they want performance.
Yes,
sounds
I
much
mean.
more like it. So
Yes,
I
and
think
no,
if you
I mean,
have
so-
a set of functional behaviors, then
Right.
up there. But if you have I want to make sure I'm not regressive,
Mhm.
then you probably want. So you need both.
Sorry, what did you say? What do
You're
I?
going to need a mixture of both.
Right.
How you're using your app? So you're running RTF on your platform?
We're not running RTF on the platform. So I think Rohit started looking into getting Joseph's tool to run for, I want to say PPCC.
For now, I was just playing with Hackband. See
Okay.
if I can record that and create the JSON.
And then how far did you get?
That's why I was like, can I even record JSON? So I'll talk offline. I was not able to. So let me maybe his GitHub has changed or something, but I'm trying to see what issues I was running into.
Because when we talk about it LPC, he said, we have this in place. Let's use it.
So what was his workload exactly?
His was some Facebook workload.
Yeah, some.
Yeah, we don't know. I mean,
And it showed his problem on his machine, but he had the actual Facebook workload. Neither did some no me could reproduce. And we had fairly similar machines at some point.
So one of the advantages of behavioral analysis is that it's try to be parameterized on the target you're running. So if in the misfit case, for example, we spawn a number of tasks which is equal to the number of little CPUs and big CPUs, we want to see that exactly when these big tasks finish, they are what would have been. And this is scalable. Just run on a different platform, we generate the current number of tasks for that behavior. Just to give another couple of examples that where I think it makes sense. In the past, we had health rewrites, and Vansan last year fixed some issues on signals propagation. Yeah. This kind of behavior that can really be described on RP. I mean, we have experiments now that if you do a task from one group to another or system to another, we verify that the signals properly migrate. Right. So these things are really something that someone send a patch, you run the behavior and see how it's breaking.
So I want to come back. You said you guys had some Firefox traces that you were running.
There are a couple of, there is one browser like JSON file and
some use case.
Yeah, and MP3 play.
Web browser on the smartphone, audio playback and video playback.
Right, and so what are you doing with that?
Is that realistic?
I
mean, that's no, I think we're the thing.
No, we haven't recorded it. We have just record the trace, analyze, and see the dependency. Because the goal of the interest is to find the periodicity and just minimize that instead of just recording. So we have spent some time analyzing the dependency and trying to find this periodicity.
Right.
Describe that.
So it isn't an actual trace.
No,
it's more like a model.
Yeah, it's a model.
Based on traces.
Right.
And the goal was mainly to show the dependency that there are several tasks that were waking up. You have a some state, and then everything is blocked, and you wake up. That's what we try to relate more than trying to be really accurate.
And so then, how do you use this? What behavior are you checking with this? Simulation.
The goal was mainly to see, for example, if for web browsing there was some small and big tasks. The big tasks are measured in big core, something like that.
Also, we can measure power, I guess.
Yeah,
for example, for the MP3 case.
But we still work differently, right? Like when we are really honest, like RT up is like we use these small functional tests.
Otherwise,
for engineers to test their patches, and then we have like more regression tests with a full-fledged Android model running real workloads and measuring power.
Yeah, for example,
so we haven't actually been able to combine both worlds.
We're really using LTF just to trigger one specific behavior that I know the scheduler cannot handle correctly in my code. For example, all the trace I had for the third update, I have used LTF just because I know that I've just created that to make sure that I will have an LT task and a CFS task running, and I can decide when the LT task wake up and sleeps, just to highlight the behavior I want to.
Right.
For example, the stuff that, for example, for the timer will write, I mean, the idle problem of yesterday, that thing will be easily put in a JSON file because you know that you want those tasks to wake up all together at a certain time. It will be easy.
No, and in this case, I guess the problem that Rohit was talking about yesterday, which with AutoNuma, how quickly is it bringing it back?
Yeah.
That sort of a thing could be easily modeled.
I guess, I mean, it's memory access. So,
I mean, you can create a sequence that you will train the CPU idle, that the average idle time is that, and then you stop your task, and normally the menu governor should mispredict.
Yeah, in your case, I guess there will be tasks having memory access phases, and then you can see if you can actually trigger the same kind of way. It won't be the same thing, but at least it will be something similar. Then you can do. You use the similar thing to actually probably be, I mean, quicker in actually evaluating, I don't know, a patch instead of running the whole workload. We just run this simple thing that might.
Right. No, and that's one of the goals, right? If I go and ask for numbers from our performance team, that's like a week,
Right.
right,
Yeah.
before we hear back from them.
Well, that's something you need to fix.
No, I mean, it's for other reasons, but it's a week. I need to have something simpler that we can run.
Well, at least something simple you can run, and you can be fairly confident that the number might look good, so they can say, okay, 30 people do the actual
Yes.
test
Yes, yeah, that's the
instead
goal.
of testing, 10 different revisions for the same
Right.
test.
In the behavioral analysis we have, usually we try to like run the same test maybe 30 or 300 times, and then we have a goal in, okay, a certain number of times has to be good, like 95% of the time has to be good. If it goes below this percentage, then we start looking at that behavior, but we know exactly when we should get.
Okay, I guess sounds fine. Can you describe like the Oracle workloads as the set of behaviors that you want from the scheduler? Just have RTF JSONs for those behaviors.
No, and that's a good question. So we know some behaviors that we have talked about, yesterday and today.
Yeah, so those things.
So there are things like that we can see immediately. But more is okay. So coming back to the original problem, which is how do we ensure we don't break each other's workloads? And
That is architecture specific. So we try to hide a lot of ARM specific stuff, especially
Right.
the big little stuff.
Yes,
So
but
it won't be,
I know-
but obviously it
well,
can
you're
be
hiding
broken.
ARM specific stuff right now, but another few months from now,
But at some point, we'll
ARM
start.
64 servers start coming out, and then
Yeah.
Also,
Well, in the case,
we'll start,
I guess, even on
we'll
people
start
with
changing the actual load balancer. That's still on the agenda somewhere. And that will affect everyone.
Yeah,
Like,
but
I mean-
the ARM server, you don't have to be so afraid because they won't be big little.
I know they won't be big little, but if you're hiding details behind the architecture,
This would be big little specific stuff.
Right.
So that we try our best not to affect you guys because we know about those issues, but obviously it's not 100% guaranteed. It's better for you to test it, right? Even though
right, which is what we try doing.
we claim not to.
Sorry,
Even though we would claim we don't affect you, but you still
Right.
want to test it.
that's there. And then the other bit is, I mean, in terms of process, it would be great if we would get reviews from you guys. If you think this will affect us, this is how it's going to make a difference.
Well, let's say that any change that you propose can be tested on the representative workloads that these guys have,
that was
and
the
the
idea.
other way around.
Yes.
So I guess everybody tests in their own
Yes.
field that no changes actually making any problem.
About the micro benchmark part, can you not extend Sysbench to behave like Oracle DB and some flag or something?
You start entering some really bad territory there that we really shouldn't be discussing here. Let me put it that way.
Sysbench does MySQL already.
Like into Oracle.
Again, like I said, we're reaching territory we don't want to be discussing here.
If it was
Oh,
just
like, okay, fine, yeah.
if it was just me, then sure.
Is this something you run into a lot of scheduler changes coming in for mobile?
I'm more worried about the other way.
Okay.
Because right now a lot of work is happening in the mobile space, and we seem to be the only folks right now who are doing big iron scheduler changes.
Okay, so you're wondering how we can prevent you breaking.
Yes, and then it should not come to this point where Peter comes to us and says, "Hey, you broke these guys." And we're
No, I mean, shit happens, I mean, we broke the Facebook thing and then we fixed it. Google occasionally pops up when they rebase. So this wasn't brilliant.
Yeah, so, I mean, one thing is, in our world, we're not running mainline stock, but there is a gap there where things can get caught and fixed.
With Facebook isn't running the very latest either, although they're very good. The Google Cloud isn't running the very latest, and they're not so very good. Want to.
Yeah.
it's essentially good
They're
members.
not running mainline either.
I mean,
But we're not very far from mainline right now.
We run mainline.
No, but yeah, what we sell is not mainline. We're pretty close. We're coming the next release, which is right now publicly available as a
You still believe in KABI, right?
I'm sorry. Didn't your previous employer
Yeah, but-
start that trend?
Well, they were wrong. And I told them. Anyway, but as long as you believe in this myth of a KAVI, you can't be near mainline ever. It's just you pick your dinosaur and then you put extra feet and extra tails on, and then you run with it.
Yeah, no, but a lot of the changes we do bring back, and we're also looking going forward. Things need to go into mainline. And there is another use case which is actually critical to mainline.
I don't know. We break stuff, we fix it. That's what we do.
The zero-day stuff is pretty cool that it identifies schedulers.
Yeah, so the zero-day stuff is pretty cool, but it requires benchmarks and things that run in a sensible time frame. And even then, it can take a number of weeks before zero-day gets around to actually running the performance benchmarks on your patches.
They are okay.
Yeah, but still, they run it, and it's good. And things that take like multi-day setup and a multi-day run, that's just not gonna happen. It's the simple benchmarks that you can install in a second and run for a few minutes. Those are brilliant. Everybody wants those. So go forth and make it happen.
No, database install alone.
Yeah, no, we're not going to talk about a database install. What we need is a synthetic workflow that would.
Yeah, maybe. I mean, the problem there is that how to detect. I mean, the way we were detecting if like a workload wasn't actually behaving as expected was like do post-processing of the trace and then do analysis on the trace.
Yeah.
So maybe we should try to understand if that's possible automatically. I mean, I have my synthetic RTF thing. I run that, collect results, and then analyze, and then says yes or no. I mean, the process should be right, but yeah, I mean, it's not something that can just run. It takes a while to configure.
You have to construct a synthetic workload. You have to construct a validation script. And
No, yeah, what I'm saying is that if we
those
start
things are
collecting,
one-time
right?
hits, right? As long as you construct them and store the workload somewhere, all you have to then do is execute it, and in your validation, you just have to.
Then I know
as long
that
as you keep your hardware, right? If you change your hardware, especially in big little, then the test cases which were once valid, they are not valid anymore. So you constantly have to adapt them if you go for
Right,
other
that
machines.
would have been one of my questions. How often are they? So then, do you have like hardware specific traces? So this is what you're going to run on,
No, we try to avoid it. But what happens if we run it on more than one big little platform? And with big little, you have the issue that the CPU capacity of the different CPUs can be like different in a different way, So this would have an influence in scheduling as well. And so we see some test cases failing on specific test
but
test
that's the
platforms.
validation that you are doing, not the test case itself.
The test case is the same.
Fine. The trace is fine.
Right.
Yeah, that was my question.
Yeah, but sometimes like the 95% will fail on specific.
In these cases, it's just because the tests that we have, they are not
Yeah. So, but we still have to. We have to fine tune them.
To have tests, and then it should be possible. They are really reading from the platform what are the parameters to generate the proper workflow. To define one specific behavior.
But this
reading
reading
is 100% always possible, but for sure we are far away from what is possible.
But this reading, like to get the information from the platform, that's constantly changing, especially in our world.
Yeah, because we don't have stable APIs.
No, it's more like the features are changing, like dynamic, for instance. All of a sudden, we don't have die level anymore. Frequency domains inside a scheduler domain. Those things are
they have to be adapted to.
Exactly.
But that's just like a changing API on you can and there represent the platform.
Yeah, but like a test case which once passed perfectly over a month will then suddenly fail. Right? Because we have this influence of topology.
You cannot have a test that will always work.
Yeah, no.
True.
Yeah, it has to be tied to the hardware.
To a certain extent, yeah.
We were just discussing the latency cache and stuff like that.
So we just recently had a discussion within our team. We are splitting test maintenance across developers because it's required. I mean, you have to know the test, how it is defined and adapt it to the new changes and make it focus.
That's what I was worried about when we talk about syntactic traces. At the performance team in SUSE, we use benchmarks, the small one that we all like, because you just read the code and you sort of understand what's going, and so they are reasonably easy to maintain over time. I'm talking about obviously Hackbench, also SCH Bench from Chris Mason, and also for the scheduler, we find interesting running netperf in localhost, and so those types of things. You look at
and sysbench and
yeah. So you look at the code and you see, oh, okay, that I get it. But with this, I don't use RTF. I'm learning here what it is, and I can imagine that those traces. I mean, you have to know what they mean, and over time they get cargo culted and say whatever. I don't know. Let's validate the trace. But
not sure. Usually that's pretty simple. I mean, it's just description of how many tasks you want to run and maybe what are the dependencies.
Okay, I don't know it. I just reacted to Patrick's comment that he said.
Actually, you don't have to look at any source code. It's better description, so it's kind of DSL. Yeah.
It's true. The key is actually to try to keep the test really simple in such a way that it's easy to maintain, but it's also exactly stimulating one specific field. Yeah. So that is the trade-off. But I mean, you can achieve the same with a patch rather than return score, and then you do a bicep and you find a patch, right? But maybe this patch contains many different bits changes here and there, right? In behavioral testing, you can pinpoint one specific bit, like okay, we are testing overutilized, then go if it's set or not, and then go and check where it's set or not.
So coming back to what can we actually do so that it's sort of easier to not have it so tied to the hardware.
But you guys
the validation script. The validation script.
You guys probably don't change as quickly as often as we do.
Yes.
Like we have more variety, and so that's already good for you probably. And you are only interested probably in performance, whereas we are interested in performance / energy consumption.
Yes. Today, yes, performance.
So
tomorrow, I don't know.
Yeah, exactly. This makes it easier probably as well.
But does it make it easier for us or for you? Because we need to know that we are not breaking you guys.
I mean, at a certain time we will see your patches, right? And
but that's the thing, right? You don't want that. You don't want that to be too late. B, we don't want to be in a position that you're only looking at your patches and not looking at the other stuff till they get merged in, because then that delays how long it takes for us to get our patches merged in. We still do need something from you guys saying, hey, okay, this looks okay.
Yeah, the most of the time for us, really, maybe validating or testing the patch, which is possible, this is that we need to backport it to our kernel.
Right.
Yeah, that's also.
But once the patch is there, if it's backported to one of the Android common kernel, then we can easily run our set of synthetics and real use cases on Android, verify if there are regressions. We do it for the patches that we post. Usually we post a mainline patch and we have a backported version just to test on a real device.
Well, maybe not on the, well, of course not on the real devices, but sometimes you can test mainline on.
Yes, there are.
Right.
So what we do, we take a snapshot of TipChat core every 2 weeks, and we try to establish like this test framework, like a bunch of synthetics on like 4 or 5 platforms.
And are you running them on real devices or on emulated devices?
Like real devices, but they are not phones. They are like
boards.
Boards, yeah.
And would it be possible for you to like make an emulator or something like that available?
No, this is answering your question. When would we see problems you are introducing the first time? This could be the moment where we could spot something. But to be honest,
but then for that it needs to go to TipChat core, and we're not even getting there.
Okay.
Or you propose a patch on the mini list is based on that, right?
Sorry?
When you propose a patch on the mini list is based on
yes, but it has to make it into TipChat core before we go ahead and actually run it.
So before we take TipChat core, obviously we scan the scheduler patches on the list, but we can only spend so much time doing this, right? There's always pressure. So yeah, so the first moment would be TipChat core. when we would see that something will break.
Right. But how quickly can we say maybe start getting reviews? As opposed to, I think right now Rohit has a one-liner which has been out for 3 weeks, 4 weeks.
I mean,
Nobody's.
Yeah, there are no real rules, right? If you're willing to review, you review. Otherwise,
Oh, he is willing to do reviews. They're kind of busy right now.
Peter, I have a maintainer question.
Oh, we have had that. Oh, we have had that discussion.
Wait, what?
One-line reviews, one-line patch reviews.
Well,
We know what you're up to.
well, that, but also, you really should know how this works. So, if I go, no, it should be bloody obvious. Why no? And if it's not, you're not doing your job right.
I don't agree with that. Sometimes you need to know, we need the big hammer to know what's wrong.
You've been around for a while. You know how this works. Anyway. You're casting stuff to atomic.
Oh, no, I'm not talking about that one. The stuff that he removed.
I don't know what that is. But more than a week ago, I don't know.
My point exactly. So what are we doing to get reviews? I mean, we're looking to see if it doesn't break your use case.
I think you're making it far more difficult than it is. I mean, just put patches and do what we can, and then if stuff breaks, we.
Well, and if you're particularly worried about what a patch might do to mobile.
Yeah, just being people.
We do.
Well, if they've seen the patch and they don't care.
Yeah, that seems fair.
So that means you should be ready to merge it, Peter.
Which one?
I don't know. Gas.
Gas is waiting.
But hearing about that, I think we should have for you.
There is a long queue of people.
So I really don't understand the complaining.
And like I said, we should know this. You've been through it.
And the size of the patch.
Yeah, that's one line and
one-line change can be as hard to review as 100 lines.
Oh, sure. I'm not disagreeing with that.
I think it's much more like if we can have those traces, make it easier for you to be comfortable with. That's what he's getting at.
I mean, to look at it and see how it fits into what we're trying to do. Yeah, we've changed many things in that over the years because things have changed.
Yeah.
I mean, when we started doing EAS, health wasn't even in the kernel yet.
So, I don't know, we haven't experienced so many
That's
things about functional treat something that is available.
It is.
It is.
Yeah, so that's what we're trying to get.
So if we can share that. Maybe
See
that's
some
that's
of the
a quick
videos.
step. From that, if that doesn't break it.
But I guess also the question is that is it worthwhile to have a single point where we collect all these synthetic
Yes.
descriptions?
Yes. Are we going to go to, like, I don't know, ARM having one set, Qualcomm having one set, Google having a third set, Oracle having a fourth set, Facebook having a fifth one?
I don't know. I mean, I guess there is a.
Actually, yes. Because everyone is responsible for taking care of their use.
Yeah.
Sure.
Okay.
So don't we already do that in the Linux kernel, even though that's just the one main line?
Yeah, because you can possibly test all the use cases on the air yourself.
Yes.
Okay, so everybody has to test anyway.
Yes.
That's one point.
But oh, that is true. And you want to be at a point saying, hey, I see this is not breaking when I run what you have made available to us. Do you mind confirming?
What you can do when you are working on a change, and try to reduce the likelihood of breaking somebody. But you can't
Yes.
prevent the person
Yes.
from breaking anyone.
Absolutely.
Well, just not to say that if he passes the benchmark or whatever, that doesn't mean that he's ready for the Yeah, you still have the responsibility to review it.
Of course, nobody is denying that. But when you reach a point where, hey, I see decent improvement on my database and I send it out, I would like somebody to come and let me know what they think.
Yeah, that's enough. Obviously, that you and I will govern or number.
Right.
20 minutes, 10 minutes.
I mean, one of the things that can be improved is like collective responsibility, like people review stuff, and maybe it's easier, right?
Yeah, no, and that's what we're trying to do. We're trying to get more involved in this.
This is why I like when Vincent and Morten are arguing, at least I don't need to.
I don't read the list every week anymore. Some weeks I do, some
Peter,
don't.
could we have something like 0-day run all these places at a central location so it's common for everyone?
I don't know.
That's what
I mean, the problem
isn't
the problem is not that running. The problem is analyzing the results.
No, I'm saying even if you have a common set, needs to run on the same hardware for everyone, so that it's not like suddenly the hardware has changed and now the numbers don't make sense.
Yes, that is true, but it also is dependent on other factors, like you just mentioned, where as the board changes, the test case might not be valid anymore.
Yeah, when you have the hardware and your test case is for that specific hardware,
Right.
that you can use.
Right.
There is rules.
Right. So on my system, for example, I wouldn't be able to run your test cases, the ones that we're talking about right now.
Sure.
So at some point in time, we need to be able to collaborate and say, okay, let's get these running together.
But the model works essentially different, right? It's not a centralized model. So
Mhm.
we all do our testing somewhere. We pay attention to different things because the architectures are still different. And if somebody doesn't participate because an architecture is dying, then it's dying anyway.
Right.
So we don't care about their specific features anymore. I think this makes the whole model like this distributed way of working together, which has some problems, yes, but I don't see that it could be like centralized because this requires a lot of overhead. Because, for instance, if we would just thinking about we would expose our internal test cases, which are ES specific, big little specific, dynamic specific. I mean, that's our business to you guys. We would have to make sure that they run on your platforms before we give them to you. Otherwise, you come back and say 50 out of 60 test cases fail. So what's the purpose? This knowledge we have inside the test cases still, we can't just expose this to you. It would be too much work.
Mm-hmm.
Not all of them are really.
But
Yeah, exactly.
We can
Yeah,
better
call that.
group
I
them.
think they've changed some hardware.
But not it's not only changing hardware, but we have different hardware, like number of
But
SMP
that comes
threads.
back to then that there is our responsibility, you're saying.
Yeah,
Our responsibility to test the
exactly.
But you think there is a core basics that are
Mhm.
common? Nice.
Yeah.
Okay, yeah.
Right, there's going to be a core, but basic set of semantics that we all have to do. Having functional tests for that, everybody agrees on. Tends to be the step.
Yes, I mean, our starting point to go off.
Somebody needs to go and write all these tests
And maintain them.
and maintain them.
Yeah.
And this is like another.
But then, that's at least that's a solvable problem once we know what these tests need to be.
The functional testing, there is a little bit of study to the beginning to understand. Like if one wants to use our framework, it's not that it comes that we write a C test and make it a little bit more generic and make it easy, for example, to have parameters that scale the test or whatever. We have a sort of framework around, make it easy to write the test. We don't write JSON files directly for RTR. We describe one task which is periodic for this number of sequences, and then we generate the thing. So, but once you understand these abstraction, writing a test which is capturing one specific need or one behavior is not really so complex, I would say, but it's true. It requires some antenna. And the way we split it, it's not because it's difficult, it requires a lot of bandwidth, but it requires a lot of knowledge about the specific behavior you want to test. So the person developing a feature, he knows better how to test that feature and how to describe it, and he has to maintain the test. That's why it doesn't be distributed,
right?
Because it's a big overhead.
Right. No, so I mean, distributed doesn't necessarily mean that the code can't live together.
No, just to clarify, that it's not a big effort. It's just the right people knowing exactly that feature is the best one to describe that behavior, and create the corner case that stress that specific code base. Or it's not necessarily code based, but like propagation of bad signals is not really tied to any specific code. We just want to see that if a task is migrated from one CPU to another or from one CPU to another, the utilization signal is properly migrated. So the implementation can change, but that behavior should be an invariant if someone said
right.
Of
right. So the first step would be to start defining this invariance.
Yes. Right. Yeah.
Maybe that's where we should be heading to. What's the common set of invariants you want to maintain for schedule burn?
So generally speaking, there is one control level metric you can have, like the one you were talking about. And now, if you should know when you write a patch, you should know which low level metrics are expected to change as a result of it. And if anything else changes, then I would start to be worried.
Yes.
You know, and that's my actually like a rule of thumb. I look at it a lot and see what changes, and those are things that I expect to change as a result of my patch. If something else is changing, maybe it's not the right thing to do.
Sometimes you can have like changes by side effects.
Oh yeah, but
so you're not really touching on it.
If I don't see any change at all, except for the ones I was expecting, then I will just push the patch, because that means
it should probably work.
It's most likely not to break anything. But then if I do see changes, I will just do that.
But see changes, you mean not looking at the code, but actually running
yeah,
something.
Actually, as a metric.
Okay.
Metrics. Like
yeah.
I have a bunch of them saved.
Yeah.
Right? Then I look at things that, changes that I'm not expecting as a result of my patch. Right? And if that happens, that indicates something may be not necessarily right. So I will investigate and I will try to understand why I see those changes at the level, and then, you know, if I understand all that.
Yeah, but then we should be able then to describe these set of metrics like invariants, features that we know.
Yeah, and that's fair enough. Like, look at those metrics. Like, if you say make a scheduler change, look at those metrics. And you know, the way I said, you always expect something to change because that's what we do patches, right? We change things. So you will expect something to change, but some things will change, but the other things will not change. Or at least you may not expect them to change. If there is anything unexpected, you should just look at it and try to understand it.
Yeah.
But the success or failure of that model
No, it may not be complete, but but at least to have a list of metrics to look at, right? Because, you know, complete is probably not.
Yeah, I don't think we don't have those. You don't want to start from the endpoint.
Yeah.
Start gathering something.
Yeah.
Step three.
But what we're trying to get to is a starting point right now.
I completely agree with the approach. Our attempt is just that we try to formalize this set of metrics in terms of a set of small tests, behavioral tests, that we want to run and verify that this invariant features is not changing by whatever change you are doing.
Oh, yeah.
So I'm not doing some work on this with the BART stuff.
Yeah.
Behavioral analysis.
Yeah, well, it's whatever we use to test TS and the synthetics that we have for these are for TS. Yeah. These are not long.
You don't need to say what to measure, actually. What to measure, and how you measure.
Yeah. Yeah. Yeah, our approach in general is to collect a trace and then with a set of sensible trace points, and then just look at the metrics and how they behave. And find framing in that case. Sometimes you don't even need a trace, you just look at specific values from the test or whatever, but not necessarily require trace. Or using EDPF. Yeah, exactly. This is other extension that we see. But that's just to be, our goal is it has to be something really simple, pointing one feature, because if it breaks, we know where potentially they are.
Right, and I think that approach starts making sense because we can also sit back and say, okay, these are the specific sets of behaviors we're interested in, and then start constructing cases around that.
Yeah, that's where RTF can help, because you can abstract from the specific workload, and the behavior usually is just you're running on CPU, or you're doing some memory operations.
Yeah, right.
You can do it or extend RTF for other features, you know, that but has to be generic.
Yeah.
Essentially, you can sort of regard it as a measurement tool, like for a specific metric, as you know, let's find the metric. And when you look at it.
Yeah.
Yes.
Sometimes we define like an initial condition, a final condition, and we want to see that there is this transition, because that's the behavior that we expect.
Yeah, that's what I'm saying, that we actually define a metric by providing.
Yeah.
Okay, so I feel like this discussion needs to be continued more, but I think lunchtime.
Yeah, it is.
So let's move the discussion on.
Thank you.
Thank you.